Hi friends, now we can see the operation of the SCHMITT trigger. Here SCHMITT trigger, it is otherwise said to be regenerative comparator. Here in this case, if we have positive feedback, this is the circuit diagram, and also if a positive feedback is added to the comparator circuit, the gain can be increased greatly. If the positive feedback is added to the circuit, comparator circuit, the gain can be increased greatly. And also the circuit, it converts an irregular shape waveform to a square wave or pulse. It just converts the irregular shaped waveform to a square wave or pulse. The circuit is otherwise said to be SCHMITT trigger or squaring circuit. It is otherwise said to be SCHMITT trigger or squaring circuit. In this SCHMITT trigger, the input voltages is applied to the negative input terminal. The input voltage is applied to the negative input terminal, and the feedback voltage is applied to the positive input terminal. Here the input voltage Vi that triggers the output V0 every time it exceeds certain voltage levels. The input voltage Vi triggers the output voltage V0 every time it exceeds certain voltage levels. These voltage levels are called as upper threshold frequency, that is denoted as VUT, and lower threshold frequency, that is given as VLT. And also that is the hysteresis width. It is the difference between these two threshold values. The difference between these two threshold values are called as the hysteresis width. It is given as VUT minus VLT. VUT minus VLT. When we are seeing the threshold voltages, the threshold voltage can be calculated as, in the first case, suppose if the output voltage V0 equal to plus Vsat. If I are giving the that is if the output voltage V0 equal to plus Vsat, then the voltage at the positive input terminal will be obtained by using the superposition theorem as, that is VUT equal to V reference R1 divided by R1 plus R2 plus R2 Vsat divided by R1 plus R2. By using this equation, we can just obtain the value of upper threshold frequency. This voltage is called the upper threshold frequency. This voltage is said to be the upper threshold frequency. Here, and also as long as if Vi is less than VUT, as long as if Vi is less than VUT, the output V0 remains constant at plus Vsat. As long as if Vi is less than VUT, the output V0 will remain constant at plus Vsat. And also when Vi is greater than VUT, the output regeneratively switches to minus Vsat and also remain at this level as long as Vi is greater than VUT. And also in the second case, if the output voltage V0 equal to minus Vsat, the voltage at the positive input terminal is VLT equal to it is given by next equation, equal to V reference R1 divided by R1 plus R2 minus R2 into Vsat divided by R1 plus R2, and this voltage is called as the lower threshold voltage. It is called as the lower threshold voltage, and also the difference between these two threshold voltages are called the hysteresis width, that is WH equal to VUT minus VLT. And also the input voltages Vi must become lesser than VLT in order to cause V0 to switch from plus Vsat to minus Vsat, and also a regenerative transition take place at the output V0 returns from minus plus Vsat to minus Vsat or at almost instantaneously. Here therefore the hysteresis width can be given by VH equal to VUT minus VLT. If we are substituting the value for the value, if both the above equation and after simplifying, we are just getting the value of VH equal to 2 R2 2 into R2 VSAT divided by R1 plus R2. And also if peak to peak input voltages Vi was smaller than Vh, then the Schmitt trigger circuit having responded at the threshold voltage by the transition in one direction could never reset itself. That is, once the output has jumped to plus Vsat, it could remain at that level and never return to minus Vsat. And it may be seen by the equation, that is Vh equal to Vut minus Vlt. In this, the hysteresis width will depend upon V reference. It depends it depends wholly upon V reference. And also the resistor R3 is chosen equal to R1 parallel to R2 to compensate for the input bias current. And some of the application of this is, it can convert a very slowly varying input voltages into a square wave output. It can convert a very slowly varying input voltage into a square wave output. Therefore, if V reference is chosen as 0, then the VUT equal to minus VLT, that is given by R2 into Vsat divided by R1 plus R2. This figure shows this graph shows the Schmitt trigger used as a square. That is we are just choosing two voltage level, VUT and VLT, that is the upper threshold frequency and lower threshold frequency. And also depending upon this VUT and VLT, when we are comparing to the input voltage Vi, it may switches from plus Vsat to minus Vsat and also from minus Vsat to plus Vsat. It is shown in this diagram. And also the next diagram shows the transfer characteristics of Vi when it is increasing and decreasing. That is first one, that is it just shows the increasing, and second one just shows the decreasing, and third one it is the composite input and output curve. It is the composite input and output curve. That's about the Schmitt trigger circuit. Okay, thank you friends.